Hey guys, and welcome back to another video on the channel. In today's video we'll be covering the Specialist Math Paper 2 Tech Active Multiple Choice booklet. This is for the QCAA syllabus in Queensland and Australia. In this video I'll be referring to a particular calcular model. So the calcular model I'll be referring to is the Casio FXCG50 AU model. So this is the calculator you need to use to solve this particular exam. Mainly because it's got a couple of functions in it like solve_n, which solves algebraic expressions, and grapho and a couple other things as well. It's got a built-in distribution thing, so it's very important that you need this calculator to solve this particular paper, unless you've got a better model, but it's very hard to find a better model other than this. Little plug in there for that. But yeah, let's get straight into it. So yeah, you will need a calculator for this particular paper, but yeah, let's get straight into it. So question 1. The position x meters at time t seconds of a 7 kilo particle is moving in a straight line given by this equation. Determine the time when the particle has a momentum of 620 kilograms meters per second. So with this question here, we need to understand what momentum is. So momentum is mass times velocity. We've got the mass is 7 kilos. We need velocity. Now we've been given a function of position in terms of t, but using our idea of kinematics and motion, we know that position, the rate of change of position with respect to time, so in other words the derivative with respect to time, is velocity. Okay, so all we got to do is differentiate this equation here. So velocity, differentiating this, bring that power down the front, so we have 3 times by 3 t squared, minus, bring that 2 down the front, so you have minus 10 t plus 2. And that's it. So v equals 9t squared minus 10t plus 2. And that's all you need to do at the moment. Now, ideally, if you were to solve this, you would get a t, and it's actually probably one of the answers here, but that is not what the question is asking. Because the question is asking is when the momentum has 620 kilos. So we need to convert this to a momentum equation. So momentum is mass times velocity, so you need to multiply this entire equation by 7. So momentum is going to be 7 times by 9t squared minus 10t plus 2. Then you're going to rub this out. Then you're going to distribute the 7. So momentum is a function of time. So you're going to have 7 times by 9 is 63 t squared minus 70t plus 14. Now, if you were to solve this at the moment, you wouldn't be able to because you don't have something equals 0. We've got two variables at the moment, but you're told when the momentum is this. So in other words, we're going to replace this term here. So we're going to replace this term here with 620 because we're asked if the momentum is that, what time is that? So if we do that, we'll just have an equation in terms of t. So 620 gives you 63 t squared minus 70t plus 14. Then you're going to make the whole equation equal 0. So in other words, I'm going to move the 620 to the other side. So I'm just going to rub this out so I have enough room. And then all you can see is we've started to have a bit of a quadratic equation there. Okay? So if I move that 620 to the other side, I'm going to have 0 equals 63t squared minus 70t minus 606. Okay? Now, if you're using the model calculator, you would want to put this straight into solve_n, and it will give you a couple answers for you. So it'll give you a positive and a negative t answer, but you're going to take the positive one because t is defined between 0 and 10, okay? Because you can't have a negative time. The only time that would make sense is if they're counting for the time before they started the clock, pretty much, okay? But yeah, quadratic equation here. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all on 2a. So you can put that into solve_n, or you can manually plug this in the calculator with the quadratic formula. So the a coefficient is 63, b is negative 70, and c is negative 606. So this means t is going to be negative b, which is negative 70, plus or minus the square root of negative 70 squared minus 4 times by 63 times by negative 606, and it just fits in there, divided by 2 times by a, which is 63. Okay, so if you put this into your calculator, you're going to get two answers, and you're going to take the positive one. So it should give you 3.706, And if you round that, it's approximately 3.71, which is D. And that's the correct answer to question 1. If you have any questions about this particular question, leave something in the comments and I'll try my best to answer it. But let's move on to the next one. So I'm just going to rub this out so it's not in the way. Right, so question 2. The Leslie matrix for a certain endangered species is given by here. So that includes the birth rates and all that stuff there. A group of species was moved to a secure property at the start of 2018. The initial female population is given, okay? The best estimate of the total population at the start of 2025. So if you were to get the total population at the start, you would have to add all these numbers together. So that'd be 150 plus 80 plus 40. We want to know the total population at the start of 2025. So if I were to multiply the matrix L by my initial population NO, that would give me the population 1 year later. So for example, since that's the start of 2018, this operation would tell me the population at the start of 2019. But with a Leslie matrix, if we raise it to the power, it can automatically do that operation for us. So for example, we don't need to take whatever result we get here and multiply by the matrix to keep going. If we raise it to a particular power, it will do that to that particular year. So for example, L squared times NO would give you the population at the start of 2020, rather than taking this particular amount here and putting it there to redo that whole operation. All you got to do is raise a power to the matrix, okay? So we need to work out how many years has passed. So in other words, 2018 to 2025. So it's going to be 2025 minus 2018, and we can see that's 7 years. So if I go L to the power of 7 times by NO, that will give me the population at the start of 2025. Now, if you put this into your calculator, you should get the following numbers. So I got 3,079.55, 831.4, and 310.4. Okay. So obviously these aren't exactly correct because you can't have 0.5 of animal or something. So all you're going to do is round it. So you're going to get 380 plus 832 plus 311. Okay. If you add those numbers together, you should get 4,223. Now notice in the question, that number doesn't appear in any of the answers, but we've got to look at the wording, the best estimate. So in other words, we've got to round this to pretty much the nearest thousand. So B is the correct answer. Okay. So yeah, if you have any questions about this particular question, leave something in the comments and I'll try my best to answer it. You want to be using, I rubbed it out, the CSIO FX CG50 AU calculator model, because you can put in matrices and raise them to particular power, so you don't have to do all these operations by hand, which would be a pain. Okay. Righto. Question 3. The masses of packages in the mass of packages of cheese produced by a company are assumed to be normally distributed with a known mean of mu grams and a standard deviation of 7.37 grams. The packages of cheese are labeled to contain 500 grams. Given there's a 25% probability that the mean mass of 20 randomly selected packages will be less than the labeled amount, the value of mu is. Okay, so what this pretty much is saying is, alright, the probability that your, let's say, your normal distribution variable less than 500 needs to give you 0.25, okay? So in other words, we need to pick a value, an average, that makes this true. So notice the word they had is randomly selected packages. So this is a sample. So in the specialist formula, we can't be using this standard deviation in our normal distribution. You need to use the new standard deviation, which is the old standard deviation divided by the sample size squared, square rooted, sorry. So the standard deviation you want to be using is 7.37 divided by the square root of 20. Okay, so a lot of people will lose their marks because they didn't do this bit first, but they said 20 randomly selected packages, so it's a sample. Okay, So ideally we want to know when this is true here, okay? So your upper bound would be 500, and in this case here you can choose your lower bound as, let's say, 0. So we want to know when this is true. So straight off the back, you would go into your calculator and you would go into statistics and you go on distribution and you go on normal, and then you would just start testing it. So for example, if we did this first number here, the probability that our normal distribution is less than 500 will be 0.74. So that's what it gives for the first one there, okay? Using this standard deviation number here, using that as the mean, and these as your lower and upper bounds. That's the number you would get. We want 0.25. So what we're going to do is, all right, we're going to test B next, okay? So if you test B, probability x less than 500, and you use this as your average, this is what you're going to get, roughly 0.43. Okay, so we're starting to get close to 0.25, but we're not quite there yet. So ideally, it's probably going to be C, because you only need to go a little bit more above. It probably won't be D. That'll probably be very too small. So let's just test C straight away. So if you put in this as your average, that is your standard deviation, and those are your bounds, you should get 0.25. And then that's the correct answer, because that's what we're after. So the correct answer is C. Wouldn't try D because it's going to be very, very small. If you did, you're roughly going to get 0.00125, which is way too small. So that's how you would do that. So you go into your calculator, go in statistics, then you go into distribution, normal, then you put in these following numbers: upper bound 500, lower bound 0. Your average is this, and your standard deviation is this number here, whatever that number gives you. Do not put in 7.37. That's wrong, okay? Because we're taking a sample. But yeah, that's how you do that one. Unfortunately, I can't really share my screen because I don't have the digital calculator, but that's how you would do it with this particular calculator model. Okay, let's move on to the next question. Let's rub that out because it's in the way. A particle is moving with simple harmonic motion described by the equation x equals 1.32 cos of pi t over 2, where x is in meters, is the displacement of the particle from the central position over time, t seconds, and t has to be greater than 0. The maximum speed of the particle is. Okay, so straight off the back, we know with motion, if you differentiate position with respect to time, you're going to get velocity. So if I differentiate this, I'm going to get a velocity equation straight away. Okay? So in other words, velocity is going to be, well, if you differentiate cos, it turns into a minus sign. So we're going to have minus 1.32. Then you have to multiply it by pi on 2 because that's the inside function. Sine of pi t over 2. Now, if you were to take pi over 2, that's approximately 1.57, okay? So your velocity is going to be minus this number times that number, which is about 2.07 sine of pi t over 2. So how I differentiate that is I saw straight away it's a chain rule because there's a function inside another function. So you differentiate the outside, so I turn the sign into a minus sign, and I differentiate the inside. So if I differentiated this function, all it turns into is its constant, and you bring that out the front door. So that's how I got my velocity equation here. Now, the maximum speed is when pretty much, we can see it's a sine curve here. It's a minus sine curve, so it kind of looks something like this, where velocity is here, but its maximum speed is going to be the amplitude, which is the number in front of the sign. So in other words, its maximum speed is either going to be positive 2.07 or minus 2.07. Now they've said speed. Speed is the magnitude of velocity. So it doesn't care about direction, it only cares about the absolute number. And the biggest velocity it's going to have is at these peaks here. So in other words, the maximum velocity is going to be A, 2.07. The amplitude of your velocity equation for this particular sine curve. And it would have been the same if it was a cos curve, because that's the maximum point it can be, okay, as we can see, if you were to graph that as well. And that's how you would answer that one. So you don't need to use any of the complex equations. All you need to do is differentiate it to get your velocity equation, and you choose the amplitude, because that's the biggest number it can have, because sine oscillates between -1 and 1. And that's how you'd answer that one. Alright, question 5. So, question 5, the gradient of a tangent at the point x, point A, on the curve y squared equals 4x is 1.36. The x coordinate of A is, okay, so this is pretty much saying, alright, dy dx, when x equals, I don't know, the A, pretty much, is going to be 1.36. So in other words, we need to find dy dx. So we have our equation here. Now it's kind of annoying at the moment, because you don't have y by itself, so you need to do it implicitly. So what you're going to do is differentiate both sides with respect to x. Now the right hand side is really easy to differentiate. It's this side we have to take apart slowly. Now, when differentiating something implicitly, we know y is a function of x. So at the moment, we just treat it like pretty much x, and we bring that power down the front and subtract the power by 1. But then you have to multiply by the inside function, and the inside function is y itself. So you go 2y times by dy dx. Then if you got to differentiate 4x, that's easy, that's just going to be 4. So now if I rearrange it, I get dy dx. If I divide both sides by 2y, it's going to be 4 over 2y, which is 2 over y, in other words. So this is a bit weird. We've got dy dx in terms of y, which is, well, ideally a independent variable, but this is not really a function at the moment. It's kind of a bent curve. But anyway, let's go with it. So we know what this is at x equals that. So if I substitute this number into here, I can find the y value for my x coordinate, and then if I take the x coordinate and put it back into the original equation, I can get my x value. So in other words, set that equal to 1.36 and solve for y. So bring the y up there and bring the 1.36 down there, so you get y equals 2 over 1.36. Okay, if you were to put that in your calculator, you should get roughly about 1.47. So the x coordinate we don't know, but we know the y coordinate. So if I take my normal equation here, if I put in this y value, I can find out what x is. So I'm going to have 1.47 squared gives me 4x. Divide by 4 will give me my x value. So x is approximately, if I put that in my calculator, 0.54, which is C. And that's how you would answer that one. So you've got to differentiate it implicitly, substitute in the gradient, find that y value, then put that y value into the original equation, find your x value, and ta-da, there it is. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it. But let's move on to question 6. Okay, so question 6, solve the matrix equation for x. Okay, so at the start, you can't really put this in your calculator, mainly because matrix algebra isn't the same as normal algebra. Go figure. Because multiplying, the order in which you multiply matrices is important. So for example, 0.123 times by 4, 5, 6, 7 is not the same as 4, 5, 6, 7 times by 0, 1, 2, 3. They're different. So what we got to do is kind of play around with it. Now there is a way you can move matrices to the other side if you multiply by its inverse. So in other words, I can move this matrix at the front to the other side. I just got to multiply by the inverse on the other side, and it has to be at the front. So in other words, I'll have x times by the matrix 4, 5, 6, 7 multiplied by 0, 1, 2, 3 inverse of this matrix here. Now, you can work this out in your calculator. if you just go in the run matrix and input a matrix, put that matrix to the power of -1, and then write that matrix next, you can work out what this will be. And if you plug that into your calculator, you should get the matrix -12, -13, 8, and 9. And now you've got this lovely equation here. Now you're probably thinking, alright, what do we do next? Well, there isn't much we can do now. Not by itself. But because there's a multiple choice question, we can take advantage of our answers here. So for example, if I just start subbing these matrices in, so if I take this matrix and multiply by this and I get this matrix, then that's the correct answer. So all we're going to do is just start doing that. So in other words, go, alright, -9, -9, 4, 4, times that by the matrix 4, 5, 6, 7. And if we get this matrix, that's correct. And straight off the back, we know it's not correct, it doesn't give me that number. So straight off the back, we know A isn't correct. Now we're going to try B. So if I go the matrix 3, -4, -1, 2, and I multiply it by 4, 5, 6, 7, it in fact gives me this matrix here. So the correct answer is B. So this question would actually almost be impossible without it being a multiple choice, because there's no way you can guess that combination without doing a lot of very hard algebra. Now this is a multiple choice question. It's not meant to take more than 3 minutes. So this is how the best way to solve this particular question in these circumstances. If you have any questions about this one, leave something in the comments and I'll try my best to answer them. But let's move on to question 7. So, the heights of all students at a school were measured. The mean height of 157 centimeters was calculated from this data. A random sample of 35 students from the school was selected. The mean height of this sample was 159.7 centimeters, with a standard deviation of 8.7 centimeters. The smallest confidence interval that could be used to produce a confidence interval, the smallest, I read that right, that contains mu based on the sample is 85%, 9%, 95%, or 99%. So a confidence interval is pretty much a bar of data that pretty much tells you how confident you are in a certain range. So what this question is asking is, alright, we know what our average is. What confidence level do we need to be at? The minimum confidence level we need to be at to include this. So for example, you want like 1.57 here on the edge of a confidence interval, and you want pretty much the average about here, 159.7. So we know pretty much this length is interval. So the length of a confidence interval is calculated by this particular formula, wherever it is. This one here. Okay. So x bar means pretty much the mean. Okay. So for example, the confidence interval x bar plus or minus the z score of the confidence interval, standard deviation over the square root of the sample square rooted. Okay. So plus or minus gives you that length. So in other words, x bar in this case is 159.7. Now the smallest interval that contains mu, you want this distance here to be the difference between 1.59.7 and 1.57. So in other words, 159.7 minus 157, whatever that number is, what is that? 2.7. So you want that length to be about 2.7 to have the smallest confidence interval. So if that length is 2.7, we can kind of work out what your z-score can be, because your confidence interval is based off a z-score. So for example, the z-score for 95% is 1.95. The z-score for 90% is about like 1.6. Stuff like that you need to pretty much remember before you enter this exam here. Okay. Actually, I'll give you the exact numbers real quick. I think I've got them in this folder over here. So these are numbers you have to remember before you go on this particular test. So the z-score for 85% is about 1.43. Z-score for 90% is 1.64. Z-score for 95% is 1.95. And I don't know what the Z-score for 99. It's probably pretty high. Maybe about 2 point something. Well, I don't know what the Z-score for 99 is, so it's probably not going to be that, hopefully. But if it is, if it's not any of these numbers here, then we assume it's going to be D, okay? But we know what this length has to be. It's going to be 2.7, pretty much. So in other words, we're going to have 2.7 equal the Z-score over the standard deviation, which was 8.7, divided by the square root of the sample, which is 35. So if I were to solve this, I get 2.7 times by the square root of 35 over 88.7 gives you your Z-score. All I did was divide by this and rearrange it. Your Z-score is approximately 1.83. Now you're probably thinking, that's none of those numbers there. But this is where we have to pretty much kind of round, okay? This number is closer to this number than 1.64. It's about 9.19 off here, and it's only about, let's say, what is that? 7 plus 5 is 12. So it's closer to 95 than it is 90. So the correct answer is C, 95. And that's how you'd answer that one. Yeah, and that's the correct answer as well. If you have any questions about this one, leave something in the comments and I'll try my best to answer it. Okay? Righto, question 8. We have complex numbers. So, let u equal 1 plus I and v equal minus 12 plus 5i. The real part of u to the 5 minus the length of v is. That is a mouthful, but let's read what this question's asking. So if you see re, that means the real part of imaginary number. So for example, re of u is just going to be 1, because it's only identifying the real part. So it'd just be the 1, not the plus, just the 1. So straight off the back, we want to get to it. Now we want to work out what u to the power of 5 is. Now we're not going to do this and expand it. That's ridiculous. What we're going to use is De Morgan's theorem. We're going to put in polar form and then take advantage of that theorem. So for example, if I draw an Argand diagram, this is what this complex number looks like. 1 unit here and 1 unit in the imaginary way. So that angle there, I can see it's 1, 1. So in other words, the angle is going to be 45 degrees or pi on 4. And the length, using Pythagoras theorem, should be the square root of 2. So u is the square root of 2 CIS pi on 4. So I'll rub that out now. So I've just put in polar form, and now I'm going to raise it to the power of 5. So De Morgan's theorem states, wherever it is, here. If you raise a complex number to that power, and it's in polar form, you raise the length to that power, and you multiply the angle by whatever you're raising to that power. So for example, since it's to the power of 5, u to the power of 5 will be the square root of 2 to the power of 5, and I multiply pi on 4 by 5. So that is the only thing I changed there, so I'll just highlight what I changed there. Those were my 5s went, okay? So that's how you work at that first bit. Now, what I'm going to do is, alright, I'm going to convert it back to Cartesian form. So in other words, u to the 5, now square root of 2 is the same as 2 to the power of half. So square root of 2 to the power of 5 is the same as 2 to the power of 5 on 2, okay? So 2 to the power of 5 on 2, CIS 5 pi on 4. Now I'm going to put that in Cartesian form. The real part is going to be 2, 5 on 2, cos 5 pi on 4, and plus the imaginary part, 2, 5 on 2, sine of 5 pi on 4 times by I. Okay? Now if you put that in your calculator, you're going to get the proper numbers. So this one, I believe, will turn into 4. So you get u to the power of 5 equals minus 4. Put that in there, it's also going to be minus 4. So again, minus 4i. So I worked out what u to the power of 5 is without doing any crazy multiplication that would have taken too long. Okay. Now mind you, this still took quite a bit, but this is pretty much where the study comes in, and you need to be practicing and you need to be pretty sharp with your polar form, because this wasn't that hard at the moment. or is just a lot of like algebra? Well, not really. And that one's done. Okay, so we've worked out what that is. V is probably the easiest part, so that's why I left it for last. So the modulus of V is going to be the square root of minus 12 squared plus 5 squared. Okay, so if you put that in your calculator, you should get 13. Okay, so in other words, the real part of u to the 5 minus the modulus of V, well, let's identify the real part here. So the real part of u to the power of 5 is just minus 4. So we have minus 4 minus 13, which is minus 17. And that is the correct answer, A. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it. Okay, let's move on to question 19. So, two objects, P and Q, move in three-dimensional space such that positions R over time are described by the following vectors until they collide. So that's the path of the particle P, and that's the path of the particle Q. So you can see they're both vector equations, and we'll work out when they collide. So collide means same place, same time. Okay? So in other words, I'm going to equate my vector equations here. So for example, I could just write them in terms of a column if I wanted to, but all I'm going to do is just equate one of the parts. So for example, what one should I use? We can use this. Let's write in a column. So this is R of P I'm writing in this column here. So we have t squared minus 4t, 2t squared minus t plus 3, and we have minus 6 plus 5t. We want to know when this is equal to particle Q, and I'll write that column there. So minus t squared plus 2t, 3t plus t squared, and then t squared here. Okay, so ideally we can see they're all quadratic equations, so all you're going to do is pretty much pick one and try and solve for it. So for example, I'm going to solve this quadratic equation here. So I would put that into solve n, so solve n of this expression here, t squared minus 4t equals minus t squared plus 2t, and solve n spits out two numbers, gives you t equals 0 or t equals 3. Now, which one is correct? Well, crossing paths means same place, same time. And I know if I were to put in t equals 0, the z components won't be the same. So for example, if I put in t equals 0 here, I'm just going to get minus 6. But if I put t equals 0 here, I'm going to get 0. And I know negative 6 doesn't equal 0, so they wouldn't be the same place, same time. So I know it doesn't work for this one. So the correct answer is 3, which is D. And that's how we would answer question 9. Okay? Let's move on to the final question of the video. The time taken by Year 7 students at a particular school to complete a standardized test is known to be normally distributed. A researcher claims the population mean is 8.2 minutes. Okay? The mean time taken to complete this test by a sample of 10 students is 8.1 minutes with a standard deviation of 1.2 minutes. Okay, so straight off the back I'm thinking samples, so n equals 10. My sample, the mean of the sample is, 8.1 minutes, and standard deviation is 1.2. So the standard deviation of the sample is going to be 1.2 over the square root of 10, because that's your sample. Okay. A 95% confidence interval is based on the sample. So the z-score for 95% confidence is 1.95. Okay. So confidence interval is calculated by this formula here, where this is s over square root of n. So in other words, we're going to have two bits. So the top bar is going to be between here, and we'll work out the top bar here. So the top bar will be, 8.1 plus, let's move that to the side actually, 8.1 plus 1.95 times by 1.2 over the square root of 10. So that's your top bar, and your bottom bar is going to be 1.81 minus 1.95 times 1.2 over the square root of 10. Okay. So now we're going to work out what each of these are. So if you plug this into your calculator, let's see what we get. Should get 7.36. And then the top one, now we can see which ones we eliminate straight away. Oh, we can work it out, it's going to be A straight away, but we're just going to double check. Plug this in your calculator and you should get 8.84. Straight off the back, we know the answer is A. Ta-da! And that is the paper done. Well, paper 2, multiple choice. So ideally, you want to do this as quickly as possible. So the reason why this video is so long is because I was explaining every step. If I was taking the test, I wouldn't be explaining it. I'd just be shoving in my calculator and solving it straight away. But yeah, try and get this done because each question is only worth 1 mark, and you want to get onto the short response because that's a lot heftier and has more marks in it. But anyway, that's Specialist Math, Paper 2, Tech Active, Multiple Choice done. If you have any questions about anything I've done in this video, leave something in the comments and I'll try my best to answer it. And I'll see you in the short response.